what to do here. So my choices are put a different transistor in that seems to work about the same, see what happens. Put the same one back in, and you know, where's that get me? That actually doesn't get me anywhere, does it, really? Other than claiming to have eliminated that particular transistor. If I put a different transistor in and we get exactly the same result with the radio, then we can be pretty sure to move on from there. If I put the same transistor back in and get the same result, then I may just still have the same bad transistor. Did I say resistor? And if I put a new one in that tests the same as the old one, I get the same result. What have I learned there? I've learned that it's time to go drink some coffee and just stop for a little bit. Well, maybe studying the schematic may be helpful at this time. Let's take a look at it and see what we can see. So this is the transistor I replaced. And this one has a weird looking output. When I touch the base, I see nothing. How can there be nothing here? Something weird here. You know, that could be the answer right there, couldn't it? Something weird going on here. But I didn't see any signal here at all. So I could locate this capacitor. We could look at either side. This would be one I've replaced. We could look either side. We can look at the input here. All the way back to here. So we know it's good here at the volume control. Something's going wrong. Well, now it appears to be this transistor. That's what's happened here. Is maybe I identified the wrong transistor initially. Maybe this is the guy who's shot. Well, I mean, the best thing to do would be to pull this out. Not the best thing, but a thing to do would be to pull this out. Do more testing. I've seen it good here. I've seen it bad here. Actually, I've seen it non-existent here, which is still a strange thing. Maybe I should look for bias voltage here. So we got R15 and R14 in series. 15 is the upper one. So we've got 10,000, we got 5,600. So is it basically 1 to 2 with the base current involved? 1 to 2. So 2 to 1. So if this is 4.5 volts, this is going to be something like a volt here. Volt and a half, something like that. Let's do that. Now this is the same type of transistor, so the base would be in the same position. So I should be able to compare actually these two. They're physically identically positioned in the radio, so to speak. Okay, let's do that. Let's do some voltage testing around these transistors. We'll see what we can find out. Okay, maybe we'll do this. Didn't I start this and then gave up on it or something? I don't know. Let's go again. Radio repair for me is a very iterative process. I tend to go over the same ground again and again, but just go a little deeper each time. So, and I understand that and I accept that when I'm doing this work. So we'll measure everything against the power supply ground, or negative terminal, I should say. I shouldn't say ground. Okay, and I see the meter is going backwards here. So let's check. That's the problem. Hey. Okay, we're ready for DC measurements. Let me zero this guy a little bit here. Turn on the radio. Let's check how much power is here first. How much voltage? So on my meter here, it's 5 volts full scale. So we're at 3.5 volts, and the radio is supposed to run with 4.5. We're going to make these voltage measurements. I think I should really push this up to 4.5 mark. It's been running just a little low. Gee, could that be the problem all the way along here? No. No, I don't think so. Okay, let me just reach around behind. Oh, that's the lights. That's turning the wrong control here. Okay, this is the right one here. Four and a half, right on the money. Now, still distorted. Don't think we need this tone on. So it is receiving a carrier, but an unmodulated carrier. So now we want to look at the voltage on those transistors and compare the same terminal, like, you know, base to base, collector to collector. It's very tricky getting in here, really. Hard to make this visible for you on camera, but here we go. Oh yeah, right. You can't do that, Jim. You need to see the meter. Let's try this again. There we go. A terminal on the transistor I did not replace. So we see 3 volts there, and on the other transistor, same terminal, 3.5 volts there. Okay, now we'll go on the base. You might hear this. On the base, we're getting the 1.5 volt scale. We're about 0.7 volts on the base, and on the other transistor, trying not to short it. Base. Oh, I did go too far. So the base is higher. Try it again here. There we are. So in this case, the base is almost the supply voltage. The base is almost the supply voltage. So you can see it 4. It's a 4 on the meter, and the supply voltage. Oh, I'm on the 1.5 scale. Take it all back. Take it all back. It's nowhere near the supply voltage. It's about 1.5 volts. So we got 0.7 on one of them and 1.5 on the other. Isn't that what I figured it should be? Roughly 1.5. Okay, now we'll go for the last terminal. This is on the replaced. They replaced. Okay, so we're seeing 1 volt there, and on the other transistor. Ooh. Isn't that noisy? And what I was doing, I was shorting something against something. That's where that noise was coming from. Okay, so 0.6. This hasn't really cleared up the picture at all. 0.6. I was looking for, total power supply voltage or a 0, something like that, which would be nice and clear. That there's something wrong. Nothing is clear here. Did we see the output of that transistor on the scope? Did we? That transistor being the this wire getting close to the antenna. Is it? I don't know. It's my hand. It's my hand. No. Okay. So not gonna make it there. To get on the base, this is not easy to do. Okay, this is going to be pretty, I'm looking on the scope here, so let's go up. It's just difficult to make contact with the base without shorting out the other pins, especially once I get in there, my hand and the tool is in the way. You can't see what you're doing with it. Okay, I'm going to get there. There we go. I don't see anything happening on the scope at all. You know, I don't really have a signal in the radio. Let me put the on. Once again, the base just shows nothing. There must be something wrong with how I'm doing this. Okay, collector or something else. I'm not seeing a thing. Tiniest little thing there. It's that weird ground thing again. Let me ground this differently. I'm thinking this ground terminal that I'm attaching to and the ground terminal on the battery is the same terminal. Guess a little peek at the schematic might help with that. Okay, let's try it again. There it is. Nothing whatsoever. Not a thing. Well, I'm going to attribute this to me doing something wrong here and how I'm making this reading. Don't know what that could be. Let's try this leg of the... So we see it. That was me grounding something by accident. This when you take the cover off, this kind of gripper cover, it exposes a piece of grounded material right here. This is so you can make measurements with tiny amounts of ground wire off of here if you can arrange it if you want. But this is bumping into other stuff. That's why you're hearing some loud clicks and pops. There. Let's go back further. There's another transistor right here. It's very easy to access. Let's just look at this one. Okay. Whoa, huge signal there. Yeah, huge signals here. thought that was a huge signal. What happened to it? Hey, something funny going on with my instrument here. Something's going on. How come this is stuck on ground? How did that happen? Okay, I got it on AC now. Son of a gun. How did that? I must have, when I was flipping this, I must have bumped this onto ground. Oh my God, yes. Yes, Peanut, I know it's upsetting to you too. Oh yeah. Yeah. So that's an earlier transistor. Look at that. Lots and lots of signal there. Lots there. Just poking around now. Show me where you've gone, Mr. Signal. Whoops, what's that? Ground. XL grounding. So where to go? It's just supposed to go this short distance here. And not really. Let's go over again. Strong here. Still here. How about the other side of that capacitor? I can't get at it. Oops. Ooh, I didn't like that. So I accidentally grounded this terminal and the operation of the radio changed a touch. Doesn't sound bad. Hard to tell when you, well, I won't say that. You're just waiting there, are you, Peanut? The signal appears to be disappearing. That's my impression now. Between this first transistor and is that really transistor number 1 there? Okay, Peanut. Can't keep you waiting all day. He's already on his way. Where are you going, man? Where do you want to go? Out? I didn't hear you. What? Where? Yeah. Show me where you want to go. Out there. Okay. That's where he wants to go. Yeah, he speaks English. Okay, I gotta stop for a while. It's just as well anyway. Go play with my cat. So now I'm looking at where exactly am I? So one of these two. I only saw one in the radio there. Where is the other one? Have I got these misunderstood entirely? So I think the one that I was testing, which was showing the strong signals, was this one. You know what? It could be this one. I've got to figure out which are which here of these three. The rest of it I think I've got sorted out fairly well, but not these three. So I really think the one I was going on was this one, the oscillator. Ooh. I'm pretty sure a piece of wire is here. I can't imagine that's open like that. Well, maybe I can, yeah. I'm going to stop for a bit and try to sort out which transistor's which in this radio. Yeah, that's a CB radio. That's not this radio. CB skip has been up for the last, I don't know, 36 hours? Day and night it seems. I get a kick out of listening to CB skip. It's crazy stuff. Anyway, back to what we're doing here. I gave up I was trying to print the schematic. I had to give up after half an hour of trying to make my printer print. Does that ever happen to you? what happened in my house is we changed our Wi-Fi system and service. Same provider, just a different level of stuff. And wow, all kinds of things don't work right now. But I made this interesting diagram here. So this interesting diagram matches the layout of the components on the radio here. So I can literally put this diagram right on top. And what I've done is I've realized, I realize now what I didn't realize before. The signal is coming in here, encountering the first transistor. This is the one I tested and had lots of signal on it. I think this is the oscillator though. It passes through a can to the next transistor, through a can to the next transistor, through a can to the volume control. And then the output of the volume control wire comes all the way to here. And we start back up this way and we encounter this transistor and this one, this one. So what we've got here is, I think, oscillator, some IF, or you call them RF amplifiers here. The little diode I changed. Where's that diode? Where's that? Yes, definitely. The diode is right here. I should have figured it out at that point. I should have realized this. So if I want to trace the signal, okay, I can't go from here to here. I'm leaving a whole bunch of stuff out. So maybe the problems lie up in here. So we're going to examine the output of these transistors, or input or output, or anyway the signal traveling along here, and see what we get. Now this is all RF. You know, I could pick it up with my tracer. I have a radio type tracer. It would detect the audio. We could hear it. We could hear if the audio is distorted. Maybe. Big maybe on that. I have to get access to certain leads on these transistors in here. But definitely worth a try. Because now, previous testing, you know what, before we do that, it seems to me the output of the volume control is fine. Well, that means all this is fine. It means everything I've been doing is fine, and this little track here I didn't catch on to doesn't mean anything, because I've already proven the signal is good coming out of all this down here. Ah, the mystery continues. Why don't we just double check this volume control output situation here? Because what happens is, as time goes by, I get a sort of weaker and weaker memory of what I did, and then I start wondering, am I really remembering what I did? So we'll just go on here. This is the output of the volume control. The radio a little noisy. Put that away from the antenna. Here we go again. Nothing on the scope. Is it really 11:15? Oh my gosh. Let me try the input to the volume control. Why am I not? So that's what's coming to the volume control. The other lead is a ground and nothing there. Oh, there is something there. What's going on here? I am not getting, maybe I'm not getting my test instruments properly grounded. Because I think I'm on a ground there. Time to examine the schematic some more. Let me just turn the radio right off here for now. So I've looked at this before and I couldn't see any reason why connecting in various grounding points seems to result in various levels of noise in the radio. And I don't understand, because to me it's all the same, isn't it? So we see coming back from up here, Feedback, I forgot about this. Feedback. Feedback. So if the feedback's not working right, then some of these strange things that are developing in the circuit wouldn't be eliminated out here where they would be if the feedback's working right. How could the feedback not work? That's a tough one to come up with. So this is the transformer or transistor I changed. With some struggling, I can probably find where R24 is. Let's just trace it back very carefully. So there it is, sitting on the output. Now this other leg, this must make it to ground. Whoop! Did I do something wrong there? Start again. So the ground comes up. Huh. Okay, so this part of the output transformer has to connect to this part somewhere. There it is. It just goes up here and right down there. And it's connected here. Yeah, that's fine. That means that, yeah, no, it doesn't. What is going on here? So this ground never makes a connection. So the speaker is floating out here. What's this one wire doing going back here? I mean, it's definitely feedback. How do you get a feedback out of a circuit here which has no relationship to ground in the radio? How's this work? These two jacks, one of them opens the speaker. So if you push something in this jack, you cut the speaker off, and then the jack wires would carry the speaker signal off to some remote speaker. If you plug it in this one, same thing happens, except you don't cut the speaker off, so you end up with two speakers running. It's kind of weird having an external speaker on a little radio like this. Okay. So this doesn't make sense to me. So why would you introduce the ground when you push? Like, why use the ground here? Like if you, let's take this one. If you plug in a speaker here, it connects to this, which is grounded. It goes down to this wire here. I keep saying grounded, but really I shouldn't really say that. It goes to here. And then you'd be getting a signal from here. Wow, this is making less sense. It'll go through the speaker, come back, and head for ground. But there is no ground. There is no ground. Is there a ground over here? How big is this guy? 17, R17. 5 ohms. There it is. So there it is. So they're not quite grounding this. Bring this in here for a reason. If you ground this directly, well, then you'd have no signal left to feed into the. You'd have no feedback signal presented into the circuit here if this just went to ground. So it can't go straight to ground. So they've lifted it with a little tiny resistor here. So that's how this is grounded. It's grounded through a 5 ohm resistor. Then what's R16? R16 is 220, not much bigger. So this would become not really a voltage divider, but yes, for other purposes, but not for feedback. So I can't quite analyze how this would really work, but there could be trouble in this circuit. Could be things like this resistor's wrong or gone bad, or maybe this one, R24, how big is that? R24, 220. So basically got a 220 and a 220 and a 5. So these radios are, transistor radios are more current oriented, so they're liable to have smaller resistors in their circuitry. That's my reasoning on that. What am I going to do here? What do I got to do? Got to do something. Got to investigate this. Got to find where R24 is. The 220. R24, it's involved in all this stuff. Maybe I can find it easily. R24. So I think that little 5 ohm resistor explains a few things here about what I've been experiencing. When I'm moving the ground from one place to another, I'm moving it from a, like when it's over, in some cases it's going through that 5 ohm resistor, let's put it that way. So I gotta be careful what I'm doing with that. So I've added to my diagram here a position of resistors in the hopes of finding R24, the feedback resistor, and it's right there. In this circuit, it's really tricky to get a test on those resistors because the leads are not exposed. Okay, let's see if I can get my scope on that resistor, even though it looks like it might have a lead I can get at here. There we go. Okay, there's stuff there. Wow, it's like a ton of RF. I wouldn't say Okay, and what does the speaker look like, and where am I grounded? So I am grounded onto the negative supply terminal. So that goes basically to 2 more resistors that form a voltage divider. What was it? It was 50, I can't remember now. That comes up into the bottom of the volume control. I gotta look at the schematic again here. I wish my printer was working, I could print it, but okay. So feedback, or the connection to ground is here, and some small voltage is applied to the bottom of this resistor. A current, and I don't know what I'm doing here. I want to try to find 16 and 17. What were they again? 220 and 5. It should be easy to spot those. That's the far side of this resistor. It's probably what I just tested right here. Let's see. Now, if you're hearing strange sounds, that's a rain hitting the windows in the next room. It's not static on the radio. And my cats are back in, by the way. They're not out there. Okay. So, you know, I've replaced all these large electrolytic capacitors. Assumably, they cannot be part of the picture of any problem that might be here. This must be a get rid of the RF capacitor. It doesn't make sense. It's on the wrong. Yeah, I don't know what it is. Oh my God, I don't know what to do here. I really don't. Let's look at the signal on the base. Did I try that already? On the base of this transistor. I've been all over this place. Right back to here. More testing. More testing. So it's a powerful, pretty good radio signal coming in there now. If we look at the input to the volume control, see if I can get the signal higher yet. I can't. It's a little hard to turn down. What I'm doing is I'm tuning this coil to change the volume. Pretty nice looking sine wave there. Coming out of the volume control. Where is it? So the problem here is this radio is not being fed with batteries. It's plugged into a power supply. Let's just take a look at the power supply. So power supply here has 3 terminals on it. This one shows a ground symbol I'm not using. So I'm using the plus and the minus, leaving the ground out. So I think it's an ungrounded output. So it's as good as a battery. So I've been concerned here about mixing up grounds on different pieces of equipment through the radio, but I don't think that's such a concern because I think there's no ground on the power supply. So that means I can apply a real ground anywhere I like. Let's get this out of here. Kind of forgot that was in there. That's my signal tracer ground. Did I just do something? No. And we're going to take the scope ground away from there, and a better place would be right on the ground stuff. You know what? This is probably good right here, this plate. Hey, radio's working better. I like that. What a noise. Oh, yeah, that's right. Bring this back here. There we are. Very, very, very low signal there. There's not much I can make out of that. The input. And there's a ton of input. The input's beautiful. That's what's going into the volume control. This is what's coming out of it. That's a weird thing, isn't it? Wouldn't you think? Okay, that's the ground off the scope right now. That's the ground placed right on the volume control. That's a little better. Yeah, I'm just guessing around here. I'm not getting anywhere at all on this. Just hoping to stumble across something at this point. So looking at the feedback. It's just looks like a pile of RF in it. It almost looks like an open wire. Let me get on the other side of this resistor. Other side of that same, of the 24, of the R24. R24 right there. If I can get on the other side, let's see. Oh yeah. Oh my gosh, look at that. That's one side of R24. And the other side of R24. It's dropping almost everything here on R24. Now R24 was it's a 220, and it was in series with a 220 and a 5 going to ground. So if it's 220 and 5 to ground, then yeah, the bulk of the signal is going to drop across the resistor. But should it look so different on the far side? What I believe is the input side here. Boy, that's ugly. That is ugly. And then on the output side of the same transistor, if I can even use those terms, is that the same looking thing, just smaller? So the top of it is really roughed up. Is that an open resistor? Is that an open resistor? Good question. Let's see. It's a little tricky to prove it's open, and I'm not just seeing a failure of the test here. Here's my little guy here. Okay, 220 ohms. Hey, see, my camera frame rate is low. 220 ohms. I don't know if I can make contact here. And if it's open, you know. Oop, something happened. $220. No, that's not 220. That's 20. Red, red, black. Oh my gosh, this is a 22 ohm resistor. Red, red, brown would be the 220. I'm on the wrong resistor, because I read it wrong. Oh my gosh. Well, okay. Let me get the close-up camera going here, and we are going to take a close-up look for that 220 resistor. So that's going to be red, red, brown. Oh, that does look red, red, brown. Oh my gosh. Why did I think it's red, red, black? That's funny. When I look with my eyes up here, my eyes are in my head up here, I'd swear that that's red, red, black. But you know, the black does have a bit of a brownish tinge to it. So, okay, 220. So that is the correct. But I'm reading 20. But that could be, it's in the circuit. Okay, so how do we get a 20 reading across R24? 20 ohm reading across R24. How do we do that? let's take a look and see what we can see. So I put my ohm meter leads on either side of this. This side, is it connected around to the other side? So let's go through here. No, yes, go up through here. No, dead ender, dead ender. Any other route? Well, through the transistor, but that's kind of crazy. No other route. So what I'm arguing is the test current from my ohm meter is forced to flow through this resistor only. Or is it going somewhere else in the radio? If you follow this side, can this side get back to this side? Well, I just kind of did that the other way around, didn't I? So this goes up, through here, up, through here. Oh, I just turned right around and came back here somehow. Up through here. There's really no other way. I don't think there's any other current path unless something is messed up. What about the speaker itself? Am I just going? I can't be going across the speaker because there's only one. It's really mysterious to me what's going on here with this arrangement. For some reason, even you plug in the speaker or a headphone jack or headphones, the current is then supplied. So the only way these jacks, wait a minute here. So this is hooked up to both jacks. Both jacks are between here and ground. That means if you plug something in, it gets its feed through the voice coil. Oh my God! Is there something wrong with this diagram here? No, it's probably something to do with synaptic errors occurring deep inside my skull. Holy smokes! Maybe that's what I need. I need the schematic of my skull on here. My brain schematic. Study that for a while. I think there's a lot of components here. Get this. You've got 100 billion brain cells. Each brain cell is connected through fibers to as many as 10,000 other cells. It doesn't stop there. Some recent discoveries are what is inside of your brain cell. Inside your brain cell are a whole bunch of these little structures called tubules. These things are atomic sized tubes built with basically one layer of atoms. So it's a tube built out of a layer of atoms. You picture that? How many of those are inside your brain cell? Thousands and thousands of them. So in each one of these tubules, as it is now being discovered, it has a big impact on what's going on, not only in your brain cell, but these tubules exist all over the place. And they seem to be little miracle machines of some unknown sort. This is brand new stuff coming out, trying to understand what's going on with these tubules. The suggestion is that there is a quantum activity occurring inside the tubules. So if you've got 100 billion brain cells, I think each one's got 1,000 tubules in it. You see the number of things, of components in your head? This is nothing here compared to what I'm using to try to understand the nothing. That's kind of funny, isn't it? Yeah, I could talk about this quite a bit more, but I'm not going to. Talk about tubules. Look it up. Tubules, brain cells. Look it up on Google. Start reading. Try to find a guy named Stuart Hameroff. If you find a video where Stuart Hameroff is being interviewed, I think you will lose touch with reality, just like I have on these issues about what's going on in our brains. It's not helping the radio any though, is it? Okay, there's a little aside there free my brain from this problem for a while. Now I'll go back at it. I'm going at it now. Going at it very strongly at this point. Well, I'm going to stop going at it. That didn't work. I went at it. Nothing came out. So if that really is R24, and if it really is 220, and if it really is measuring 20, there is something wrong here. That's what I would determine. There is no way for this lead to find its way to this side. Let's just do this one more time. No, because this wire is basically open circuited up here. There's only one wire coming back out of here, which is really mysterious to me. This is an isolated circuit. It has nothing to do directly with all the rest of the radio. That's a loosely true statement. Except one wire comes out of it. I mean, this is like holding a battery here and sticking one wire on the positive and bringing it down and thinking it's going to do something. You got to have a circuit. So it could be some kind of capacitive thing going on inside this transformer that gives enough. I don't know. Gives enough of a second connection to make one. I don't know. I'm all turned around on this little radio. Is this definitely feedback? Is this definitely a feedback line? You know, it must be. We're feeding back at the input to the output transistors. So you want to feed back as close as you can to these guys. Because what happens if you send the feedback back further? Why'd you say that, Jim? Well, what you're going to correct is problems that are detectable out here, like as distortions that are occurring out here, which do not match the distortions occurring here. And assumably there are no distortions, but we've looked at this and it's crazy on the scope. So the distortions apparent here could start back here, but they can be knocked off or countered for by the feedback, by this negative feedback that's coming back here. Boy, oh boy, I don't know. I don't know what to think here. That'd be easier if it was a bigger problem on the radio. I don't know. I'm stuck. I gotta stop. I gotta stop and ponder and think some more. Well, if I don't know what to do, I'm going to gather some more information. I'm going to try something different to gather new information. I'm going to try feeding an audio signal into the radio. I'm going to feed it in. These are the two output transistors. I'm going to feed it into this transformer here as if it's the output from this transistor. So I'm going to feed in an audio signal here. We'll hear what it sounds like coming out the other side. I don't want this around. I'm going to want to do it through a capacitor here because hooking up equipment can cause problems. Let's try this one here. The input side was back here. This is turned off right now. Yep. Okay, take my signal generator. We'll use this one here. It's sweeping around 1,000 hertz. So low sweep, 1,000 hertz. Not sure what we got there, but we got something. Why don't we hear it? Let's hear what it sounds like. You just got to be sure of everything. It's better to be sure of everything. There, mark that down. That's a life fact. Better to be sure of everything. There we are. Okay, no question. Signal's there. You have the grounding problem again. I'm going to go on this plate. Turn this up. Turn this down. It didn't do much, did it? Turn right up. Don't need this turned up. I can't tell. Well, what I'm doing here is I'm killing the different signals, the oscillator and the radio signal, by putting my finger here. Trying anyway. Just so we could hear the tone better. That's all I got to put into it. Let's stop the whooping. There we go. Well, doesn't sound terrible, does it? Okay, so what if I put the signal into the volume control, despite the radio signal that's here? That's on the input of the volume control there. About the same. Let's dump it into the output. There's a rushing sound that comes with it. Okay, it's fun to do. Don't know how it's helping me at all, but inject a signal into the base of the transistor that is feeding there. Okay, we can try that. Oh my gosh, it's afternoon. I'm going to try to touch this wire on the base. Let's cut this way back. Hang on. Nothing. Whoops. I hit the output there for a moment. Well, that's funny. So I hit the base of that transistor, nothing happened. I don't understand it. So we'll go to base of the transistor ahead of it. That's on the base. Hot dog. Well, that sounded fine. What that tells me then is what is getting to the base of that transistor is not a nice signal that we can listen to from the radio. So where am I now? Now I'm heading away from the output circuits completely. Stick this in the volume control. Just past, so stick it on the detector. Oh, this I'm not sure what to do here. Let's try it. Well, it didn't work very well. Putting on the detector had a surprising effect there. It's possible I'm just using a big capacitor. I'm literally grounding the signal away completely at that point. How come we don't hear the how come we don't hear it? I'm on the wrong end of that diode. Maybe that's what it is. Get on the other end of it. I've got to come up from underneath. One side, that's the other of the diode. Scope around to the metal plate. Let's bring a signal in now and see what it looks like. Oh my gosh, you know what? Oh my gosh, oh my gosh. Well, I've done a whole pile of testing with the radio not tuned to the signal generator. We've been listening to something a little off to the side here. Well, okay, you know, maybe that's good news, in fact. Got to tune the radio up in frequency here. Yeah, wow. I made a big boo-boo. There's so much signal coming from the signal generator and out of this coil that a little bit was enough for me to think that was it. And there's a whole bunch more. Okay. Tune the signal generator here. It really quiets down the radio, doesn't it? Now, let's take a look at the scope here. The scope is showing me exactly what I would expect to see. I'm going to increase the percentage of modulation on the signal. We'll see what happens here. How bad does that sound? Well, this is a correct signal to see at the detector. And we want to see just kind of past there. I believe is straight out to the volume control. Let's take a look at the schematic here and be sure of that. So we're talking about the detector straight to the volume control. Yeah, sure is. So we're listening right here. Or we're looking at it on the scope right here, and it looks pretty good, but that's not a detected signal yet. Maybe I'm on this side. Let's flip over to the other side here. It's easy, just go to the top of the volume control. Okay, so we'll switch from here, top of the volume control. And there you can see the detected result. A little noisy, but it looks like a fairly well-defined sine wave. I don't see a big problem with that. So let's jump onto the speaker now. Let's see what that looks like. Hey, what's happening there? A few times now this radio has done this weird thumpery stuff when I don't know. Okay. One side. Other side. Yeah. And that's what's making it to the speaker. So very clearly, at the volume control it looks okay. By the time it gets to the speaker, it looks like that. Okay, just kind of, remember, iterative, over and over and over. Over and over and over we go, round and around and around. And it's time for lunch.